Friends, I welcome you to my YouTube channel MacPM. So this is our third video on operation research and linear programming. So in this video also we will use graphical method to minimize the problem. In last video we have maximized our objective function. In this video we will minimize our objective function. So let's see how to do. So we have been given a function which have to be minimized. So this is z is equal to 3x1 plus 2x2. This is our objective function. We always remember that the thing which you have to minimize or maximize is always objective function. Your objective is to minimize, which of course should be the cost for the company. So we have to minimize the cost of company and maximize the profit. So in this case we have to minimize. So obviously this should be the cost to the company. So let's see how to do. First of all, we have various constraints. These are 5 constraints: 1, 2, 3, and 4, 5. 5 constraints are given to us. So first of all, we will write this in inequality form. So we have to write it in equality. So we will write our constraint like this: 5x1 plus x2 is equal to 10. Second constraint is x1 plus x2 is equal to 6. Third one is x1 plus 4x2 is equal to 12. Fourth one is x1 is equal to 0. Fifth one is x2 is equal to 0. So how to solve this? First of all, we have to find, we will make a graph. We have two variables, so we will make a graph in two variables, x1 and x2. This is x1, this is x2, this is our origin 0 0. So first of all we have to draw a line which is 5x1 plus x2 is equal to 10. So we can write it as like 5x1 plus x2 is equal to 10, or 5x1 by 10 plus x2 by 10 is equal to 1, or x1 by 2 plus x2 by 10 is equal to 1. You can compare it with x by a plus y by b is equal to 1. So a is intersect in x1 x-axis, and here it is x1, and b is intersect on x2 axis, y2 axis, which is here x2. So it will be on x-axis intersect is 2, so it will be 2 0. So we will draw the various points here, divisions: 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Let's see if we will have more value, then we will extend it. And here also 1. We will divide the graph. So our x-axis intersect is 2, so it is 2 0. So this is here 2 0, and y-axis intersect is 10 0 10. So it is here. So this is a line. We have to join 10 with, sorry, we have to join 10 with 2. So this is our first line, which is 5x1 plus x2 is equal to 10. So we will mark it first line. Then our second line is x1 plus x2 is equal to 6. So x1 plus x2 is equal to 6. We can put x1 is equal to 0, then we will get x2 is equal to 6. And similarly x2 is equal to 0, then x1 is equal to 6, or x1 by 6 plus x2 by 6 is equal to 1. So we will get 0 6 here and 6 0 here, sorry, 6 0 here and 0 6 here. These are intercepts. So this is our second line. Okay, What is our third constraint? X1 plus 4x2 is equal to 12. X1 plus 4x2 is equal to 12. So we'll divide by 12. X1 by 12 plus 4x2 by 12 is equal to 1, which will become x1 by 12 plus x2 by 3 is equal to 1. So we'll get 12 0 here and 3 0 3. So it is our third line. It is going here. So it is third line. Our fourth constraint is x1 is equal to 0. Where is x1 is equal to 0? This line, y axis or x2 axis, and x2 is equal to 0 is x1 axis. So these are the 5 lines. So now we will see the inequalities. For drawing the lines, we have made the inequalities into equalities, but now we will see the inequalities. So it is 5x1 plus x2 is equal to greater than or equal to 10. So this is line for 5x1 plus x2 is greater than or equal to 10. So if we put the values here in left side, like suppose it is 0 0 here, so I put 0 0. If 5x1 is 0, x2 is 0, then it is not greater than or equal to 10. Okay, so we have to put the values of the right side of this line. So we have to choose this area. Suppose we put 10, x1 is equal to 10, x2 is equal to 10, then it will be 50 plus 10 is equal to 60, which is always greater than or equal to 10. So this area satisfies the equation. So we have to choose the area of this line, which is right side of this line. Okay, this side. If it is less than or equal to, then we have to choose left side, and if it is right side greater than or equal to, then we have to choose right side. Then second line is x1 plus x2 is greater than or equal to 6. So this is this line, so it will be also right side. Then third line is x1 plus 4x2 is greater than or equal to 12. So it will be this right side of this line. And x1 is greater than or equal to 0 and x2 is greater than or equal to 0 will be above this line, x1 line, and right side of this line. So what area is the common in all the conditions? So this area, you can see, this area, it is common for all. So this is our feasible region. Means if we will choose any value from this region, then it will satisfy our objective function. So let's so to minimize the problem, what we have to do, let's highlight it first. I have highlighted it so that you can see it clearly. So suppose this is point A, this is point B, this is point C, this is point D. So what we have to do, that we have to find the value of Z at these extreme points at A, B, C and D, because at any of these extreme points we will find the minimum value of Z. What is Z? We will write again. Z is equal to 3x1 plus 2x2. Okay, and what is point A? Point A is, we will write point, we will make a column, point, coordinates, value of Z. Okay, so what is the point A? This is point B, this is point C, this is point D. What is the coordinate of point A? It is 0 10, because here x is 0 and this is origin. Here x is 0 and y is equal to 10. We don't know the coordinates of point B yet, and coordinate of point C. We have coordinates of point D, which is equal to 12 0. we have to find the coordinates of point B and point C. So we know that point B is intersection between these two lines. So what are these two lines? First line is 5x1 plus x2 is equal to 10, and second line is x1 plus x2 is equal to 6. So if we solve this equation, then we will find the coordinate of this point B. So if we minus this, we we deduct the equation number 2 from equation number 1, then we will get 4x1, this x2 minus x2 will be 0, is equal to 10 minus 6 is 4. So x1 is equal to 4 by 4 is 1. If we put the value of x1 in this equation number 2, then we will get 1 plus x2 is equal to 6, x2 is equal to 5. Okay, so our coordinate will become x1 x2 will become 1 and 5. Okay, so we will write the coordinate of point B is equal to 1 and 5. Point C is intersection between this line and this line. So we will again write x1 plus x2 is equal to 6 and x1 plus 4x2 is equal to 12. Again we will, this is equation number 3, this is equation number 4. We will deduct equation number 4 from equation number 3. It will be minus x1 minus x1 is equal to 0, x2 minus 4x2 is minus 3x2 is equal to 6 minus 12 is minus 6. So minus sign will cancel minus sign, x2 will become 6 by 3 which is equal to 2. So here put value of x2 in equation number 3, we will get x1 plus 2 is equal to 6. So x1 is equal to 6 minus 2 is equal to 4. So coordinate will be 4 and 2. So we will write the value 4 and 2 here. Now these are the extreme points. We have to find the value of z at these extreme points. So value of z is 3x1 plus 2x2, 3x1 plus 2x2. Put the value of x1 and x2 here. We will get 3 into x1 is 0 here, plus 2 into 10 is equal to 0 plus 20, which is 20. So here we will see that at point B, the value of z is 3 into x1 is 1 plus 2 into x2 is 5, which will be equal to 3 plus 10, which is 13. Now at point C, value of z is 3 into x1, which is 4, plus 2 into 2, which is equal to 12 plus 4 is equal to 16. At point D, value of z is 3 into x1 is 12 plus 2 into x2 is 0, which is equal to 36. So we can see that minimum value of z is 13, and we had to minimize the objective function z. So our answer is z is equal to 13. So z is 13 at which point? At 1 and 5. So 1 and 5 at point B. So value of cost will be minimum at point B, which is z is equal to 13, and we have to select x1 is equal to 1 unit and x2 is equal to 5 unit to get the least cost. I hope you understood this problem. If you have any doubt, then please ask in the comment section. If you liked our video, then please subscribe to our channel. Thanks for watching.